Now it's exercise 1.3. List the first 5 multiples of 12. Multiples are actually the numbers that you obtain by multiplying a number by some positive integer. Like for example, you can think of these numbers to be the times table. Like for example, for part A, 12, if you multiply 12 by 1, then 12 times 2, 36, 48, and 12 fives are 60. So these are the multiples of 12, the first 5 ones. So that would be the answer to part A. Similarly, for part B, 3 ones are 3, then 6, 9, 12, 15 are the first 5 multiples of 3. Similarly, for part C, 5 ones are 5, 5 twos are 10, 15. For part D, 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40. For 9 is 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, 9 fives are 45, and so on. For part F, multiples of 10, 10, 10 twos are 20, 30, 40, and 50. Part G, again, multiples of 12. So we are done with that thing in part A. And for part H, the multiples of 100 are 100 ones are 100, 100 twos are 200, then 300, then 400, then 500. So this is how we solve question number 1. Okay, now in question number 2, use a calculator to find and list the first 10 multiples of 29. So this is how it is to be done. For we need to use calculator. This is 29. Ones are is obviously 29, the same number. Then 29 twos are, that is 58. Then 29 threes are 87. Then 29 fours are, which is 116. And then fives are, that is 145. So this is how you need to do it. Like 29 times 1, 29 times 2. Since we need to use the calculator to solve it, so that would make it very simple to solve. Actually, 116 and 29, 145, so on. In the same way, the rest of the parts can be done. Okay, then for part question number 3, list the multiples of 4 which are between 29 and 54, 53. So multiples of 4. Then 4 7 are 28, 4 8s are 32, 36, 40, 44, 48, and 52. These are the multiples of 4 between 29 and 53. The multiples of 50 which are less than 400. Okay, for part B. 100, 350. You cannot write down 400 because you need to have less than 400. So this won't be there. So part C, the multiples of 100 between 4,000 and 5,000. Multiples of 100. 100 ones are as 100, 100 twos are 200, then 300, 400, 500, 600, 700, 800, 1,000. And with the same pattern of increasing another 100, you can come up till like this. These are the multiples of 100. But since you need to have them between 4,000 and 5,000, so we won't start from here. These are just the multiples of 100 to fulfill this condition. So 4,001, 4,200, 43, 4,400, 45, 4,600, 4,700, 4,800, 4,900. So that will give you the required answer. Okay, in question number 4, here are 5 numbers. Which of these are multiples of 12? What you need to do, you need to check them using your calculator. If these are completely divisible by 12, so you say that these are multiples of 12. 576, when you divide it by 12, you get 48, a whole number. So that means, yes, 576 is a multiple of 12. Okay, then 396, you divide it by 12, you get 33. So yes, 396 is a multiple of 12. Then 354. When you divide it by 12, you get a decimal number. 354 divided by 12. You get 29.5. This is a decimal number. So this is not a multiple of 12. Same goes similarly for, you need to check it for 792 divided by 12. That divides it completely. 792. So yes, 792 is a multiple of 12. And then 1164. When you divide it by 12, you get 97. This is a whole number. So yes, 1164 is a multiple of 12. Only 354 was not the multiple of 12. Rest all are the multiples of 12. Okay. Now in the same pattern, it is question number 5. Which of the following numbers are not multiples of 27? So you need to see one thing in previous question was like you could see for the multiples of 12, the number which should be divisible by 3, divisible by 4, that would have been the divisible of 12 as well. Since for that you need to do it a bit more working, you need to check it for 3, then by 4 as well. So instead of doing it twice, so we have just divided it with 12 completely. For question number 5, which of the following numbers are not multiples of 27? So 324 divided by 27. The answer is 12. Yes, that means 324 is a multiple of 27. So you won't be including it into the answer because you need to answer for the numbers which are not multiple of 27. Okay, now 783 divided by 27. That divides it completely as well. Answer is 29. So that would not be included. This would not be included. Then 816. You get 30.22. So that means 816 is into the required set of numbers for 837. That divides it completely as well. So that means 837 would not be included into this category. Then for 1116, you get 41.33. That means it is not completely divisible by 27. So yes, the second number in the required answer of yours, that is going to be 1116. So these two are the required numbers. So this is how we had to do exercise 1.3. Okay, for exercise 1.4, find the lowest common multiple of 2 and 5. Since these are the prime numbers, so only both of them are divisible by 1. So that means LCM is the product of these prime factors. The LCM is 10. For part B, 8 and 12, 8 and 10, 2 fours are, 2 fives are, 2 twos are, and then 5, 1 are. So 5 twos are is 10 and 2 twos are is 4. 4 times 10, that is 40. Okay, have you got it? Then part C, 6 and 4. 2 threes are 2, 2 1 are. 3 is 1 times 3. So 3 twos are 6, 6 twos are 12. So this answer is 12. Similarly, for part D, the lowest common multiple of 3 and 9. 3 ones are 3. So 3 threes are 9. The LCM is going to be 9. The LCM of 35 and 55 in part E, 5 7 are 5 11. Now these are prime numbers. 7 ones are 7. So this is, you can do it in either of the ways. 11 7 are 77. 77 times 5. 5 7 are 35. 5 7 are 35 and 3. 3 80. And then 6 and 11. 6 and 11. Okay. This is part F, the LCM of 6 and 11. 2 threes are 11. 3, 11. 11 threes are 33. And then 33 twos are is 66. This is answer to part F. Okay. Question number 2. Is it possible to find the highest common multiple of 2 or more numbers? Give a reason for your answer. Highest common multiple of two or more numbers. Highest common factor can be found out, but not the highest common multiple. Because, like for example, we talk about 2 and 5. You need to find out common multiple of two or more numbers. So 2 and 5. Common multiples are common multiples are in this case 1 only, and in part B, for example, or part C, the common multiple of 6 and 12. 6 and 4 was 12. If you need to find out the highest of that, so that is not possible to calculate. Like, for example, if you have a multiple of 99, that would be this one. But then you can have the next multiple of 12. Then you can have even the next multiple of 12. So whatever the number you get, you can get the next number of that number. So that's why the highest of the common multiples is not possible to calculate. So this is how this exercise 1.4 is to be.